Have you ever wondered what the world will look like in 50 years? Or 100? Science fiction has given us flying cars and teleporters, but the reality might be even more mind-blowing thanks to two revolutionary fields: quantum computing and nanotechnology. These aren't just buzzwords from a sci-fi movie. They are the building blocks of our future, and they're developing faster than you can imagine. Let's start with quantum computing. Your current laptop or smartphone works with bits, which are like tiny light switches, either a 0 or a 1. It's a simple binary system. Now imagine a switch that can be both on and off at the same time, and also a whole spectrum of states in between. That's a qubit, the fundamental unit of a quantum computer. This ability, called superposition, along with another strange quantum property called entanglement, allows quantum computers to process a mind-boggling amount of information simultaneously. So what does that actually mean for us? Think about the biggest challenges facing humanity. Curing diseases like Alzheimer's or cancer requires understanding incredibly complex biological systems. A classical computer would take thousands of years to simulate a single protein folding correctly. A quantum computer could potentially do it in minutes. This would revolutionize drug discovery, allowing us to design new medicines atom by atom, perfectly tailored to a specific disease, with fewer side effects. It's like having a superpower to see and manipulate the very blueprint of life. Or consider climate change. Developing new materials to capture carbon from the atmosphere or creating ultra-efficient batteries for renewable energy are monumental tasks. Quantum computers can simulate molecular interactions with incredible precision, helping us invent materials that we can't even dream of today. We could design new catalysts that make industrial processes cleaner and more efficient, or create solar panels that capture energy with near-perfect efficiency. The fight against climate change could get a powerful new ally. And it's not just about solving big problems. Quantum computing will also redefine fields like finance, where it could create unhackable encryption and optimize financial markets in ways that prevent crashes. It will supercharge artificial intelligence, leading to AI that can learn and reason in ways that are much more human-like. The possibilities are truly staggering, and we're just at the dawn of this new era. Now, let's zoom in from the cosmic scale of computation to the impossibly small world of nanotechnology. We're talking about engineering on the scale of atoms and molecules. A nanometer is 1 billionth of a meter. To put that in perspective, a single human hair is about 80,000 nanometers wide. At this tiny scale, the rules of physics change, and materials can gain extraordinary new properties. What can we do with this? Well, the applications are practically limitless. Let's go back to medicine. Imagine tiny nanobots, smaller than a red blood cell, circulating in your bloodstream. Their mission: to hunt down and destroy cancer cells one by one, leaving healthy cells completely untouched. This isn't science fiction. Scientists are already developing nanoparticles that can deliver chemotherapy drugs directly to tumors, drastically reducing the brutal side effects of treatment. In the future, these nanobots could even perform surgery from inside your body, repairing damaged tissue at the cellular level. Nanotechnology will also transform the materials we use every day. Think about your smartphone screen. With a nanotech coating, it could become completely scratch-proof, waterproof, and even self-healing. Your clothes could be made from smart fabrics that regulate your body temperature, repel stains, and even monitor your health. Buildings could be constructed with nano-enhanced concrete that's stronger, lighter, and can even repair its own cracks. We could have water filters so effective they can turn seawater into pure drinking water with minimal energy, helping to solve water scarcity around the globe. Now here's where it gets really exciting. What happens when we combine the immense power of quantum computing with the precision of nanotechnology? This is where the future truly begins. Imagine using a quantum computer to design the perfect nanobot. It could simulate billions of potential designs in a matter of seconds to create a nanobot optimized for a specific task, whether it's repairing a damaged artery or building a microscopic computer chip. Quantum computers could guide the self-assembly of these nanostructures, essentially telling atoms where to go, to build complex machines from the ground up. This synergy could lead to breakthroughs we can barely comprehend. We could create a nanofactory, a desktop-sized device that can assemble products atom by atom from a supply of basic elements. Need a new phone? Just download the blueprint and the nanofactory builds it for you. This would completely upend manufacturing, eliminate waste, and make goods accessible to everyone. It could also lead to a true merger of biology and technology. Quantum-designed nanobots could integrate with our own cells, augmenting our abilities. They could repair aging-related damage at the source, potentially extending human lifespan and health span significantly. They could connect our brains directly to a quantum cloud, allowing us to access information and communicate just by thinking. This sounds like the stuff of dreams, but the foundational science is already being put into place. Of course, with great power comes great responsibility. The development of these technologies raises important ethical questions. How do we ensure quantum encryption is used for good and not to break all current security systems? How do we regulate nanobots in our bodies and in the environment? Who controls these powerful tools, and how do we ensure they benefit all of humanity, not just a select few? These are conversations we need to start having right now, as the technology develops, not after it's already here. But the potential for good is undeniable. We are standing on the brink of a new industrial revolution, one that will be defined by our ability to control matter and information at the most fundamental levels. Quantum computing and nanotechnology aren't just separate fields of science. They are two sides of the same coin, unlocking a future of unprecedented health, sustainability, and human potential. The world of tomorrow is being built today, one qubit and one nanoparticle at a time. It's a future that's smaller than an atom, yet bigger than we can possibly imagine. Thanks so much for watching. If you're as excited about the future as I am, make sure to hit that like button and subscribe for more deep dives into the technologies that are shaping our world. Let me know in the comments what you think the biggest breakthrough from quantum and nanotech will be. See you in the next one.